All right, so let's go ahead and get started with expressions and variables. So the first thing that we should go over is, what is a numerical expression? A numerical expression consists of numbers and operations. So for example, an example of a numerical expression could be 4 plus 10, 4 minus 10, 10 minus 4, 4 times 10, 10 divided by 4. All of those are examples of numerical expressions. They contain numbers and operations. Now, it is important to note that when it comes to multiplication and division, there are a couple different ways that you can write numerical expressions. So 4 times 10 can be written like this with the parentheses, or a dot can be used. Also, an X can be used. And then when it comes to division, the most common thing you're going to see is a fraction. Something like that. So again, those are all examples of numerical expressions in different ways that you can write them. Coming back up to this multiplication one here, I tried to avoid using this way of writing multiplication because in a minute you're going to see that we're going to get into variables, and your most common variable is an X, and so it can get confusing if this is a multiplication sign or if it's a variable. So I like to use the dot, or the most common one that I use is going to be parentheses, because that's the most straightforward to me. But again, it's totally up to you, whatever you're most comfortable with and whatever makes most sense to you and you don't get confused about, go ahead and use that expression. So let's go ahead now and define what a variable is. So a variable is a letter used to represent a number. So a variable expression is going to be an expression that consists of numbers, operations, and variables. So for example, you might have an expression that looks something like that, 10 minus x, or 10x, 10 plus x, x plus 10, 10 divided by x. All those are variable expressions, and in all of these cases, x is your variable. And then oftentimes you'll be asked to evaluate a variable expression or just evaluate an expression. And what it means by that is that you're going to substitute a number for your variable and then perform the operations within that expression and get a final answer. So if we were asked to evaluate the variable expression 10x, where x equals 4, we're going to go ahead and take this here. So we're going to plug 4 in for x, in our variable expression. So that's going to be equal to 10 times 4. And then you just perform that multiplication, so 40. And that's going to be our answer. And that's how you evaluate an expression. Another example, we can do a division one. If we say evaluate the expression when x equals 2, and our expression is 10 over x, again, we're just going to take this number here and plug it into the expression for this variable. So we're going to plug 2 in for x. So 10 over 2 equals 5, and that's your final answer. Now, these can get a little bit more tricky. If we say that we know that a equals 2, b equals 15, and c equals 3, and we're given the expression a plus b over c plus 17, and we're asked to evaluate this expression, we're going to plug 2 in for a, 15 in for b, and 3 in for c. So a equals 2, so we're going to have 2, plus b equals 15, so we'll have 15. C equals 3, so we'll have 3 down here, and then plus 17. And then you just go ahead and evaluate that. So 2 plus 15 divided by 3 is going to be 5, plus 17. 2 plus 5 is 7, plus 17. 7 plus 17 is going to be equal to 24. So that's how you would evaluate that expression. Again, you're just going to take the value and plug it in for its variable in the expression and then solve for your final answer. Now, another thing that you might be asked to do when it comes to variable expressions is to write the variable expression. So, write the variable expression. And you'll be given something like 16 more than a number, 2 less than a number, product of a number and 2, things like that. And so to write a variable expression for each of these, you're just going to first identify keywords, and then logically write expression. So, in this first one, 16 more than a number. The words that are going to be important, your keywords for this one, are going to be more than. So another way of interpreting more than is going to be addition. Because you want to add on to become more than this number. So we know that our expression is going to have an addition sign in there, and we need 16 more than a number. So 16 more than a number, and that's going to be your expression. Now in the second one, Our keywords are going to be less than. So that's opposite of more than. So we're going to have subtraction, and it's 2 less than a number. So 2 less than some number. So some number minus 2 is going to be 2 less than this number. And then finally, this last one, your keyword is going to be product. So that's going to be multiplication. And so it's going to be the product of some number and 2. So x times 2, which we often write as 2x. So that's just how you're going to write a variable expression from these words. All right, so that's really all we've got on variables and expressions. So let's go ahead and move now to powers and exponents. So the first thing you're going to want to know is what is a power, what is an exponent? So a power is a result of a repeated multiplication of the same factor. So power equals repeated multiplication. And your power is expressed by writing your base with an exponent. So for example, if we had a repeated multiplication, let's say 3 times 3 times 3. So repeated multiplication of the same factor. So we've got the same factor and there's repeated multiplication. So your base is going to be your 3 and your exponent is going to be your the number of times it's multiplied. So again, your base is going to be that repeated factor. So if we write this expression here, so 3 times 3 times 3, our base is going to be 3, and our exponent is also going to be 3. So this is your base. This is your exponent. And your exponent is written above, and it's a little bit smaller than what your base is written at. So just another example of that. We're going to have, let's say we've got 2.4 times 2.4. To write an expression for this in exponent form, we're going to have our base, which is the repeated factor, so 2.4, and the number of them, 1, 2. So that's going to be your expression there. Now, how you would say this in words, this is going to be 2.4 squared, because it has a 2. If there's a 3 as your exponent, it's going to be cubed. So in this case, it's going to be x cubed. If we had it to the 4th, it's going to be x raised to the 4th power. If we had 5 as our exponent, it's going to be x raised to the 5th power, and so on as you go down. The only two that have special wording that goes along with them is squared and cubed. All right, so let's go ahead and evaluate some of these exponential expressions. Evaluate. So if we wanted to know 10 squared, that's going to be 10 times by itself 2 times. So that's going to be 100. Now if we had 7 raised to the 4th power, that's going to be your base, which is 7, multiplied by itself 4 times. Which is 2,401. And then, of course, you can have variables brought into these expressions as well. So if we said that x equals 4, and we have the expression x squared, again, you just replace this 4 where the x is in the expression. So that's going to be equal to 4 squared, which is 4 times 4, which is 16. Or if we had 2 to the x, again, you just replace x with the 4 up here, so 2 to the 4th. So that's going to be 2 times itself 4 times, so 1, 2, 3, 4. So if we do these times each other, we're going to get 4 times 4, which is 16. So that's really all the information we've got on powers and exponents. So let's go ahead and move now to order of operations. So the order of operations is going to help you know how to evaluate more complicated expressions. And the thing that I always learned was PEMDAS, where that is parentheses E stands for exponents, M stands for multiply, D stands for divide, A stands for add, and S subtract. This is going to be the order in which you evaluate different expressions. Now, there are a couple things that you have to remember about this. If you are going to use this acronym, it isn't foolproof. So these are grouped together and these are grouped together as one. So you don't necessarily do all your multiplication before you divide, but you're going to do your multiplication and divide in the same step, and you're just going to evaluate it from left to right. And that's same with add and subtract. You do these at the same step. You just move left to right as you do them. So first, you're going to do your everything inside your parentheses. Then you're going to do all your exponents. Then you're going to do your multiply, divide. And then you're going to add and subtract. So 1 parentheses, 2 exponents, 3 multiply and divide, and then 4 add and subtract. Now, another thing to point out as well, that every time you go inside a parentheses, then you start your whole order of operations over again. So each parentheses kind of stands as an expression on its own, and so it gets its own set of order of operations. And that also goes for if you have some fraction and you have an expression up here and an expression up here. This gets its own set of order of operations, this gets its own set of order of operations, and then you apply the fraction at the end. All right, so let's go ahead and run through an example. And I'll try to give you kind of a nasty one so we can try to get all of these in here. So let's go with 9 plus 10 minus 6 squared. Ooh, let's do 3 squared times by 7 plus 2 plus 4 and we'll square that as well, and then we'll add on a 9 squared. Okay, so our first step is to do our parentheses. So in this case, we've got these parentheses here. Let's use a different color. So we've got these parentheses here. We've got brackets here. And we've got parentheses here. So I always liked, when you have multiple parentheses, you just need to make sure you get all the parentheses done. So I just like to work left to right with my parentheses. So let's go ahead and look at these ones first. So we've got 10 minus 3 squared. So again, your parentheses gets its own set of order of operations. So we go back up to the beginning, we look at this expression, we go, there are no parentheses, so we move on to our second step, which is exponents. Let me write this over here for you. So we've done this one. We're going to go ahead and move on to exponents. So we've got an exponent expression here. So we're going to go ahead and do that first. So 10 minus 3 times 3. So then 10 minus 3 times 3 is 9. So now we do our multiplication, division, which we don't have any of those. And then we move on to our add and subtract, and we do that left to right. So 10 minus 9 equals 1. So we're going to have a 1 that we're going to place right here in that expression. So then we can go ahead and move on to our next set of parentheses, which are going to be these brackets here, which is just a fancy kind of parentheses, which go around other parentheses. So if we look in there, we've got 7 plus 2 times 9 plus 4. So again, we're inside parentheses, so it gets its own set of order of operations. So we're going to start with parentheses. Here we've got two different sets of parentheses. So we're going to go ahead and start with this first one. 7 plus 2, that equals 9. And then we'll go ahead and move on to the next set of parentheses. 9 plus 4, which equals 13. So we're going to plug a 9 in right here and a 13 in right here. So we're going to get 9 times 13. So we've done our parentheses. There are no exponents. So now we can go ahead and move on to multiplication. So 9 times 13 equals 117. So this whole expression here, we're going to replace with a 117. All right, so now we're going to go ahead and rewrite this expression. So we've got 9 plus our first set of parentheses. We found the answer to be 1. And then our second set of parentheses we found is equal to 117, and that's squared plus 9 squared. All right, so now we come back to our order of operations. We've taken care of all of our parentheses. So now we can go ahead and move on to our exponents, of which we have two different ones. So we've got this one and we've got this one. So 117 squared and 9 squared. 13,689, and that's going to be 81. So we can go ahead and rewrite our expression again. So 9 plus 1, 13,689 plus 81. And then, so we've done now all of our exponents. So now we can do our multiplication and division. So we've got a multiplication here. So 1 times 13,689 is just going to be 13,689. So 9 plus 13,689 plus 81. There are no more multiplication and divisions left, so that's done. Now we move on to our add and subtract. And again, we do that left to right. So we're going to do this 9 plus 13,689 first. So it's going to be 13,698 plus 81. And then we just add 81 onto that, and we'll get 13,779. And that's our final answer for that nasty expression that we started with up here. So again, just follow through with your order of operations and you will be all right.